this video, I'll show how to refer line impedance from the primary to the secondary side of the relays, because relays protect they're used to protect transmission lines, and the input to the relays are CTs and also voltage transformers. So I'll do this through a quick example. It's always to help if you have an example. So we have a 17-mile 138 kV transmission line. It has an impedance, so the resistance is 0.15 ohms per mile, and the reactance is 0.61 ohms per mile. This line is protected by a line relay, which has input sources as follows. So you have current transformers with a ratio. So CTR just stands for current transformer ratio, 1200 amps to 5 amp, and potential transformers connected as 139,260 volts grounded Y. That's the primary, and the secondary is 116.05 volts grounded Y. So potential transformer, it can be a VT voltage transformer or a CCVT capacitor coupling voltage transformer. So question one is, what is the line impedance, the primary ohms in per unit on a 100 MVA base? The second question is, what is the transmission line impedance in ohms seen by the line relay on the secondary side at a 0.65% of the transmission line? So the first question is line impedance in per unit. So anytime you're dealing with per unit, you have to have a base. So the base impedance, the general kind of equation when you have three-phase. So it's a kV squared divided by MVA base. kV squared, this is a 138 kV. So it's squared divided by 100 MVA, which is the base. And notice when you square, so you have kilovolt here. So kilo means 1,000 basically. So if you square that, it becomes 1 million, or 10 to the power of 6. And notice here, MVA, it's mega, which is 10 to the 6. So basically they cancel out. So it's important to watch out the units. So if you carry out the calculation, the base impedance is 190.44 ohms. Now the impedance in primary ohms is basically resistance plus J times the reactance. So the line is 17 miles long, and the resistance is 0.15 ohms per mile, and the reactance is 0.61 ohms per mile. So if you multiply that, you get 10.5 plus J times 42.7 ohms. So then if you want per unit, you take the impedance in ohms, basically this here, divided by the base in ohms, which is this impedance here. And notice here I calculate this one is in rectangular form, and I also calculated it in polar form. So I just used the polar form here. So if you carry out the calculation, you get 0 0.23088 with an angle of 76.18 degrees per unit. So now, question 2, we want to calculate the line impedance referred to the secondary side at a 65% of the transmission line. So first of all, we know the CT ratio is 1200 divided by 5, which is 240. The PT ratio is 139,260 divided by 116.05. So this is line to line. So as long as you're consistent, it's okay. And this is line to neutral, basically. Basically, it's line to line divided by square root of 3. So you have to be careful not to mix line to line and the line to neutral. So if you have line to line divided by line to line, you are fine. Or line to neutral divided by line to neutral is fine. So the ratio is 1200. Otherwise, you're going to be off by a factor of square root of 3. Basically, square root of 3, which is 1.732. For instance, if you divide the line-to-line voltage by line to neutral. So you're going to be off. You don't want to do that. So then the secondary impedance, we know it's just Ohm's law, voltage of the secondary side divided by the current of the secondary side. Then if I want to use the ratios to refer from one side to the other. So the secondary voltage is the primary voltage divided by the PT ratio. And I do the same thing for current. Current in the secondary is the current in the primary divided by CT ratio. So if I rearrange this formula here, I get the primary voltage divided by the primary current times the CT ratio divided by the PT ratio. And what is this here? This is just Ohm's law basically, so it's just Z, the primary impedance. So the primary impedance times the CT ratio divided by the PT ratio. So now the question was, we want to calculate the secondary or the line impedance referred to the secondary side at a point 65% of the line. So then I just do 65 or 0.65 times, when now the line is 70 miles, times the primary impedance. This was given. That way mile will cancel out, and I get times the CT ratio divided by the PT ratio. So if you carry out the calculation, you get 1.365 plus J 5.551, or if you want it in polar form, it's 5.72 with an angle of 76.18 ohms. So thank you, thank you, and hope this video will help. Have a great day.